Eldritch, thanks so much for popping in. Hope you sleep well. Also, it's nothing to apologize for there. Thunder, hey. Central, hi. Congratulations on the 4th and the 1st. Thanks for the YouTube stream is going. It's been giving me some difficulty the last 2 times now. Alright, there we go. They did, Spetry. You got anything for me today, Thunder? Or are you just chilling? Either way is fine, but I'm probably gonna do some kind of studying if not. I think Critical's probably gonna be around some questions too at some point. Hey, underscore, you're chilling? All right, glad to hear it. Hey, underscore. Oh wait, I was about to say hi to you twice. I don't know, dude. I feel like it's so hard to keep my thoughts straight when I'm streaming. I forget things that I like literally just did. That looks like Tyler 1 to me, but I assume it's not. I've seen the email before, and it always looks like Tyler 1 to be honest. I don't know if there's like a meme attached to it or not though. Oh, he's this like pretty big streamer. Hey, it's G1. I know him because I used to be super into League of Legends, and he like made his name on being super toxic. And he blew up big there. He got banned for a while. He started doing a variety of stuff, and then he got unbanned somehow. I am debating if I want to do physics or algebra in this moment. Oh, really? That looks exactly like Tyler 1 to me, at least. I'm doing good at SG1. How are you doing? How's your week just starting? Yeah, I'm doing this physics reading group. It only just started, so our first meeting is hopefully going to be this Saturday at my normal start time. Great. That's great to hear, SG1. I appreciate you coming by as often as you do. So yeah, by this, I've read all of chapter 1 as of last night, which is what our kind of goal is for everyone who's interested to read it by next Saturday. It's not like there's rules though. I need to go back through and read the early sections because it took me so long to get through like these last sections here that I want to go through and reread the first sections. I feel like I've forgotten them all now. Yeah, I kind of chose it because it'd be a little on the intense side. Like it's actually Gauss's law, exactly, yeah. So it starts off with Coulomb's law expressed in vector form here. I feel like when I learned it, we only ever talk about the magnitude. And we figure out the direction like independently, like with geometry. I don't remember though. And then they go down to Gauss's law and they show like here's a really tedious Coulomb's law calculation, or here's the 2-line Gauss's law calculation. Yes, like right here's where they get into Gauss's law. The derivation is pretty cool. I'm still trying to figure out this one bit here with geometrically what a couple of pieces here are doing. Yeah, it's probably been like, I haven't done physics since my freshman year of college, which is actually probably around 2014. Dude, I kind of hate thinking about that though. That's nearly 10 years ago. I think I did. Wait, if I'm 27 now, I basically graduated high school 10 years ago, which yeah. That feels weird. Um, so yeah, it does use multivariable calculus. It actually doesn't rest that much on it though. Like they'll show like what the setup would be, but it boils down to a single integral all the time. Hey, Ultimate Yeet, it is. Fallout New Vegas is probably my favorite game of all time. So, and I'm in California, so I feel like the NCR flag is very fitting. But Fallout in general has some pretty cool merch. I should check now that the show has come out. There's probably some new merch. In this field of a line charge, I have some nostalgia when I read through this one because I remember doing this exact calculation during the physics class that I took, and I thought it was the most stupid thing I've seen in my life. It was like burned into my mind as like, why the hell would I ever need this? But now that I see it again, it's actually, I kind of like it. Some of the setup that they do is a little weird to me, but they do all this like work here using Coulomb's law, and then this little paragraph is all you need if you use Gauss's law. Played like 2 hours of Fallout 4 and that's it. Oh god. See, now I hate Fallout 4. I think it's... I haven't played every Fallout game, to be fair. I played Fallout 1, but I need to play Fallout 2 still. And then there's also a few like Brotherhood Tactics or whatever, like side games, but I think it's the worst Fallout game that I played. I don't like Fallout 4 at all. Then I hear vectors, you get flashbacks. I know, I was just thinking of that too. Because there's this weird dot product thing that I was just reading yesterday too that I was trying to wrestle with. Let me see. And I was thinking exactly of that ball problem. It didn't feel like at the time, but I went back when I was getting timestamps for like what problems I was doing at what point during that stream. That was like 45 minutes or an hour just debating about the dot product. Yeah, here they have this. And also, there's apparently a quantum particle called a pion, which I thought the book was just making things up until I actually Googled pion. And it's a real thing. You don't think you did much of anything? It's been years? Oh, fair. Participate in this math combo, a little too smooth-brained. No worries. I mean, I'm struggling with this stuff to be fair. But, made of 2 quarks, yeah. Not everything that I do is like this complicated. This is like a reading group that we've been kind of studying, or that like we've been studying just in part because I want something to do in my downtime when people don't have questions. Another part, I think this is just some interesting stuff, but usually the math I'm doing is like ideally like calculus and below. Pion has no strange quirks as well. Ooh, I mean, I don't know what part of physics that's even called, like quantum. Is that considered quantum physics? But, when it comes to like quarks and all that stuff, I know very little, or like other particles besides protons and electrons. Oh, particle physics. Yeah, that's probably it. Particle physics slash theoretical physics. Okay. But yeah, another thing I'm doing in the downtime, which I'm still kind of debating what I want to do, is Penn Center is doing this abstract algebra reading group that I've been like reading along with. I forgot to read chapter 4. I meant to do that yesterday and I didn't. Have you heard about exchange particles? No. We've never seen a strange quark. We've only ever seen normal quarks. Exchange particles. Oh, I do. Yes, I learned about the term virtual particles as like I read Stephen Hawking's book, A Brief History of Time. It goes into this and how like forces, even like gravity and electricity and all that, they actually act on other things by sending out these virtual particles, which it makes sense. So because like they don't just randomly attract things, there has to be some kind of interaction. It's still super weird to think about. Like a W boson, pion, virtual photon, graviton. Okay. Now what's a strange quark? Higgs boson. I've heard that. Yeah, I've heard of it. I don't remember what's up with it though, or like anything about it. Subatomic particles of hadrons. Strange D mesons? Sigma baryons? These sound like dinosaurs. Gray goo? Down quark, but strange. Oh yeah, you know, quarks do have some like fun names, right? Like there's charm quark, stuff like that. Like whoever into a lot of these quirks like had some fun with it. It's much more fun than using Greek letters and exhausting the Greek alphabet like multiple times over. And so Higgs boson. Up, down, top, bottom, charm, and strange. Okay. What's so special about the Higgs boson? I think so, yeah, Thunder. And this is the URL does say Kern right there, so Higgs boson exchange particle for mass. Ooh, okay. What is the shape of this? I'm getting distracted. Oh god. Is there... Is that a gamma that's in that thing? Maybe that's gamma radiation or something? I don't know. Anyway. Annihilation is your favorite part of physics? When like, with like antiparticles? Yeah, I only know, I mean, they talk about it a little bit actually in this book. You like doing the calculations with them. You're doing some cool physics, and I've never done anything with antiparticles. I don't remember. It's gonna take me too long to figure out where it is. Your reading's like spaghetti to me. Oh, okay. Here's where they're talking about like a little bit of the particle physics stuff. Never used integration. Really? So I specifically looked for physics that is pretty heavy on the calculus because I'm interested in the calculus part of it more than the. I mean, the physics part is cool too, but I think multivariable calculus is just kind of fun. And I asked a physics streamer if physics and depression kind of like if there is any crossover between like I mean, I'm sure there is, but like what the crossover between multivariable calculus and physics looks like. It turns out actually isn't that much, but upstream maximum, I guess, is a place where it can come in handy. About particle physics in the LHC, because you did a project on it in the past, but no actual math. Oh, okay. Hey, AS Gaming Bros. How's it going? Um, I realize E equals MGH is the same as W. Honestly, dude, same. This book just started saying that the work done to create a system is equal to the potential energy, and I never learned that. I always just learned work as this weird thing that we were forced to calculate and then never actually use. Good, just wrote an IT exam today. Ooh, I hope it went well. But it makes sense when I hear that the work done is equal to the potential energy. Like I imagine like pushing a boulder up a hill or something, and then that boulder has potential energy, and you did work to put that boulder there. You did multiple engineering classes and barely use work. Really? I mean, yeah, I never have done classes that like would need to use work, so I wasn't sure if it's something that's actually helpful or not, but I hope so too. It's like when you say an IT exam, do you mean like for a certification, or are you like studying IT in school? It took you solid 3 months to realize energy and work done are basically the same thing. It seems like it, yeah. Or like there's literally like integrating this force, find the potential energy of a system of charges, the work necessary to bring them in from infinity equals this double summation down here. Is it 10 less than you thought you would have all the lessons? Yeah. In school? Okay, cool. Hey, Anders. Oh, you know what? I mean, man, I should maybe say, I mean, I could always just bring it up again during the actual reading group, but it's the first time I've seen a physics book using a proof by contradiction. It kind of made me laugh because I never think of physics as needing a proof of anything. Right here, they calculate the electric field due to this like a hemisphere, and to prove that the electric field can't be going diagonally, it has to be going straight up from this flat part. They use the proof by contradiction. It's oops down here in this like remark part. But I feel like maybe I should do abstract algebra because I mean, it's not like that bad a thing to like discuss it too much before the actual reading group happens, but proof by contradiction is horrible. I mean, a lot of times it's easier. It gives you like a little more to like chew on when you have a proof. Like doing a direct proof for me is often harder. Infinite prime number proof. Ooh, I never looked at that proof. I don't think I have, at least. Maybe I'll show this in a class actually at some point. This actually looks a little more familiar now. Makes it look 10 times harder than it actually is. I believe it. This is the part of math, like the history math, I think is super interesting, which is that like the math notation is relatively recent. Like it's maybe 500 years old when Descartes laid the foundations for it. But you know, people have been doing math for thousands of years, so the way that math is presented in historical text is really different from what we're used to. Euclid often, reported to have proved this result by contradiction, beginning with the assumption the finite set initially contains all prime numbers. And it doesn't seem like the work. I mean, I only kind of skimmed it, but like, you assume that you take a list of primes, you assume it's every single prime, and then you find one more. I know that I would have figured this out on my own, but though it is actually a proof by cases, a direct proof method. Oh, it's technically not even a proof by contradiction. Oh, since you don't use the assumption of the it being all primes. Okay. Hey, Skirtle. Oh, you know what? I noticed that like Senny has that emote back, and I wonder why it's allowed on Twitch now. Or I thought it got removed or something. Either way, it's a good emote, so I'm glad to see it. But Twitch just allowed it. Ooh, okay. There's an actual like change in the rules. Oh, I didn't hear about that. The big brain. Now we can get a me twerking emote too. Oh, you had a twerking duck? Oh yeah. I think I'm gonna start reading through chapter 4 of the abstract algebra stuff. I meant to do this off stream, but I guess we'll do it on stream. Hey Phobos, how's it going? All right, cyclic groups. We finally have moved on to a new chapter. You did, Phobos. As soon as I put the physics away and took out the algebra, you were there. The dot product gives a magnitude in simple terms. It's not, yeah. I mean, it's a little more complicated than like just the magnitude, but the magnitude is involved. The cross product, it gets you a vector that is perpendicular to the initial two vectors. So if you have, in 2 dimensions, if you have two vectors that go like that, the cross product, like, I need a third hand, but the cross product will like pop out 3-dimensionally and like point right at you, and that's also scaled by how in alignment they are, I think. Today was an awful day. Last night before going to bed, I had devastating news. Oh no! I'm so sorry to hear that, Anders. I really hope that you're able to, I guess, find out what happened. But no, no need to apologize. Yeah, I'm sorry. I'm not good at like come up with words in situations like these, but I really hope that things work out as well as they can with that. Um, it's been since I even thought about abstract algebra, so I'm gonna have to like switch gears in my brain. From chapter 3 that a group G is called cyclic if there's an element A and G such that okay, if it's cyclic if there is an element that generates the entire group. Which element's called generator. Okay. One and -1 are generators of Z under addition. Oh, I wouldn't think of this as cyclic because it's infinite, but I guess it is. In addition, mod n is cyclic. Z has 2 generators, Z may have many, depending on the n. Okay. C sub A is generated by 1, 3, 5, and 7. All of which are relatively prime to 8. I mean, they're just prime numbers in general, I guess. Oh god, Thunder. We can take a look. You know what? Now I think about the cross product, it's actually scaled reverse. The closer the vectors are to 90 degrees apart, the bigger the cross product in magnitude. If the vectors are right in line, the cross product is actually 0 if they're perfectly parallel. Did you even try it? Okay. Sounds good. Actually, I imagine that an even number can never generate a group. Hey, Bruno, how's it going? So maybe even just odd numbers in general can generate groups. For addition. I'm no good too. Thanks for asking. Since things are a little bit slow for questions from chat right now, I'm just reading through a little bit of an abstract algebra textbook and doing a little bit of like studying. Oh, that's piqued Anders' interest. I guess the last dot product question that we looked at from Thunder involved a lot of physics. I got stuck on it for a long time, but just as a warning. A non-example is helpful in understanding content as an example. You have 8. Hey, Fembox. How's it going today? Art and algebra? I don't think I have. I'm on page 99 right now. This is Joseph A. Gallien's Contemporary Abstract Algebra. Art and algebra I never heard of, or anything that sounds like it, I don't think. See the question, Thunder? Question 2, challenge? Okay. So we're looking at number 2 here in the box. I probably need to scroll down a little bit. Is there anything more? Oh no, that's the end with B at the bottom. Diagram shows arbitrary vectors A, B, and C. The vector B plus C. Oh. A dot B plus C equals the magnitude of A times PQ. You don't know how to do question 1, you just take it for granted? Oh, you know what? Question 1, I think, is 2 steps. We can do, I see how to do question 1 right off the bat here. I'm gonna go to the whiteboard, so if someone wants to take a, or if someone wants a problem for themselves, you should take a screenshot quick. Because this problem is gonna be too big for me to show it on screen. Well, it might be small enough if I scale it, but let's actually try that. I can do that, I guess. Okay. So they want us to use the fact that A dot B equals magnitude of A times magnitude of B times cosine theta. And all that we do here is we know that multiplication of scalars is commutative, so we're allowed to switch A and B as much as we want. So I'm going to say this thing is equal to magnitude of B times magnitude of A times cosine theta. And then I'm going to conveniently notice that this exactly matches the definition of dot product for B dot A. So I think that's all that you need to do for question 1 here to prove that the dot product is also commutative. Where are the tips of the arrows at the middle of the segment? Ooh, that's weird. I think it's just their convention, Anders. That definitely is weird though. Yeah, but I think that's all that question 1 takes. Now, question 2 is going to be a lot more involved. What the heck? A dot B plus C equal to magnitude of A times the length of segment PQ? B plus C. Oh my god. You don't understand what I wrote in the second and third line? Like these 2 lines? So the idea is we want to prove that the dot product is commutative. And so we can't use, we're not allowed, we want to prove that it's okay to switch B and A as much as we want, which is why these proofs look a little bit weird. So we don't know yet that it's okay to switch A and B in this situation, but we know that the dot product is defined by this thing right here, magnitude of A times magnitude of B times cosine theta. All 3 of these are scalars which have known properties. If you multiply a scalar by a scalar, that's commutative. You're allowed to switch 2 scalars. Like 2 times 3 is equal to 3 times 2. I'm using the same exact property with A and B. And I'm doing that because now we could ignore the stuff up here and conveniently notice that magnitude of B times magnitude of A cosine theta is the definition of the dot product for B dot A. And then if I take it away, remember that we came from A dot B, we just prove that it's equal to B dot A. Okay, no worries. Hey Moo. Why is the normal product commutative? They did not declare it to be a field. I think we don't have to go that deep, I don't think. Finbox is giving a hint for part 2A. PQ is equal to the magnitude of B plus C. Okay, it's using a right triangle. Okay, that's clever. Finbox using right triangles. All right, I think I'm gonna need to redraw this. I'm gonna erase this, so I think I need to draw the vectors here. Is this linked to the physics vector question you gave before? No. This can help you understand what a dot product is, I guess, but aside from they both use vectors and dot products, that's about where the association ends as far as I can tell. P, M, Q. Why isn't the upper right point named? Anyway, make it more clear that this point right here is Q, right angle, right angle. Okay. Assuming the unit vector B plus C from P to the end of the line. Yeah, I think we can take it as the end of the line as I drew it here with the arrows on the very end, I think the book just uses a weird convention for vectors with the arrow in the middle. So PQ is equal to... Okay, so first off, we want to show A dot B plus C is equal to the magnitude of A. Now, that's times scalar multiplication, the length of segment PQ. That's not a cross product, importantly. It's supposed to be... Is Q supposed to be at the end of A? Q... That's a good question. This is where the notation really falls short, because I don't actually know. It seems like Q is not necessarily at the end of A. A could go on more. We're just saying that Q is wherever these vectors end, or I don't know about even that much, I guess, technically. These vectors could be longer, I guess. Well, no, if this is B plus C, I think it's just these vectors do end here, but A might go on for longer. I can emphasize that, I guess. But this is why we draw the arrows in the end, so it's not ambiguous like that. Okay. So first off, let's use the definition of dot product on this left side just to see if that gives us something that we can try to build towards with on the right side. So A dot B plus C is equal to the magnitude of A times the magnitude of B plus C times cosine, and we specifically want the angle between A and B plus C, which the problem gives us theta, conveniently. What's the bigger angle? Alpha? Okay. Give an angle up there for beta. Okay. In the story I'm using Venn boxes, they're assuming 2b equals pm. You think? Hey, math professor. All right, let's see. But then what is B? Then why have they drawn B plus C like that? I guess it's still true if we translated C over. Vector A is just a shorter vector that points in the same direction as vector PQ. Points, huh. I assume it's for a reason that they do that for the whatever proofs are going to be happening later. All right. I guess that's fair. I don't like it, but it's fair. So these vectors do end. And I think it's like vector B just like ends there like halfway. Vector C ends halfway there. Vector A ends, well, we don't know halfway because A just like, that segment trails off. But I think what it's saying is that this is a vector and this is a line segment, or at least maybe part of some bigger vector, which makes me uncomfortable, but I guess we can do. Uh, and they draw it in this super weird way because they want to show that they want to use this rectangle in these proofs and some right triangles and stuff. And they want to show that even if those vectors don't perfectly make a rectangle, if they aren't big enough or, the proportions aren't right, this proof still works. So that's why they're doing it in this super weird, unintuitive way. Okay, so looking at this proof, we've broken out a dot b plus c just to see what it looks like. We need to deal with this a, or magnitude of a times length of the line segment PQ. And what Venn pointed out is that we actually have a right triangle with P and Q, with B plus C as the hypotenuse. Oh. So I'm just like separating out this triangle over here just to make it a bit more clear what's happening. That's B plus C, that's theta, and that's just PQ, I guess. This we don't even care about. But just using right angles and trig there, we can say that PQ is equal to B plus C times cosine theta, the magnitude of B plus C. Actually, I should include that because we're talking about the length of a line segment. Oops. Just elbowed my wall. So what I can say is that PQ, the length of that segment, is equal to the hypotenuse of the triangle, which happens to be the magnitude of B plus C, times cosine of theta, which is the same exact, these two theta are the same exact thing. And look what you have, we have a little sub that we can do here now. So I'm gonna draw an arrow from this line down here to that line. Probably there's a much better way to organize this proof than I just did there, but using this fact here, we're gonna sub this part for PQ. So we have the magnitude of A times PQ. So I'd say that's a proof for part A. Part 1. Part A part. Yeah, exactly that. Thunder. Using the symbol for cross product. Yeah, Anders, that threw me off. Oh, really, Moo? It might not make that much of a difference, I guess. Because we're just proving things like generally about vectors. Like if we could always scale them how we want them. I don't know. Yeah, none of these use the cross product now that I look down the list. Let's go part 2. I want to show A dot B equals A times PR, we said? Okay. Don, isn't A dot BC equal to PQ? No. It's equal to the magnitude of A times PQ. The reason that we just showed. The magnitude of B plus C on its own is equal to PQ. So if you dot it with A, then you're really just multiplying by A's magnitude. But yeah, the magnitude of this vector on its own is PQ. Well, times cosine theta, but. Yes. Sorry, I corrected myself at the end, but I was saying it wrong. It's the magnitude of b plus c times cosine theta is pq. Or like we just proved exactly why. I guess if you got a dot b plus c is equal to just pq, then like we're proving a different question, but that wouldn't even be true here. So a dot b, a and b dotted is equal to the magnitude of a times PR. So I assume we can, yeah, I think it's going to be the same exact technique here, to be honest. So let's first break out what a dot b actually means. It's equal to the magnitude of a times the magnitude of b times cosine of the angle between a and b, which is alpha now. And now let's look at what PR means, but using another right triangle with PMR. That angle is alpha. That's a right angle. Oh, wait. Pn isn't exactly the magnitude of b plus c. I did make a simplification there. It's okay, though. Oh, you have to go, Anders? All right. Well, thanks for hanging out. Yeah, there's like a little weird distinction here where b plus c only goes halfway through pn, and same with b only going halfway through pm, but I think we can just ignore that. Or, I mean, depending on how you interpret it. Either way, I don't think that's the point of the problem. You know, for this proof to work, and the proof before, these vectors should go the full length. Otherwise, we should have a scaling factor. Because we can't make, okay, I feel like making this too complicated. There's a weird thing going on here with the lengths of the vectors, and I'm kind of playing fast and loose with it, but I can't make the claim that the magnitude of vector b plus c is equal to the length of the segment Pn if we take Math Professor and Anders's comments to heart. And we don't necessarily know that it's even split in half. So I feel like the vectors are drawn in the middle, or the arrows are in the middle, not at the end. Because otherwise these proofs just don't work. So I don't think it's part of important. I think maybe we should just do the actual proof here, but like, these vectors are weird. Or the picture kind of disturbs me with the ambiguity, but if I don't overthink that part and just draw the right triangle and I think do what they want us to do here, we can notice that the length of PR is equal to PM times cosine alpha. And PM, this is the part where it gets weird, we're just going to say it's the same as the vector B, even though it's drawn weirdly. I don't think the proof works without that fact being true. So A dot B, sorry, I skipped over part of the proof, didn't I? Or so that means the magnitude of A times PR is equal to the magnitude of A times PM cosine alpha. Just subbing out that PR for the PM cosine alpha. And this is where B, like I think B must go the entire length because we can't say that the magnitude of B is equal to PM without that fact. So I'm making the claim that PM is equal to the magnitude of B cosine alpha, which equals 8. Oh my god. A dot B. So from that line to that line, we've gotten our proof, I guess. I'm not in love with how I'm organizing these. So I was debating that in my head, Thunder, because if we did say that this vector B only goes up half. Oh. TMOH, thanks for the follow. The answer says so. So I think they are the same. It was just the picture being unclear because the arrow is drawn halfway up. You could maybe interpret this as a vector with a line segment on the end, like Anderson math professor were saying. But I think that's not what they want you to do, the more that I look at it. And I think that Moo is right with their comment. But I was just getting confused on this whole arrow only going halfway up the segment, where it's like, you know, you'd have to multiply this vector by 2 to actually get to the end at M, and that's where things would get weird. But I don't think that it's supposed to be like that. So I think what I've written on the board is correct. And so part 3, A dot C. Oh, really, Moo? Okay. It's not something that I'm used to. So, I mean, I guess that doesn't mean that it's wrong, but now part B looks hard. There should be some kind of substitution that we can do there. Do you want to work through part 3 first? A dot C. Working with A dot C and RQ. That one's gonna be a little bit harder. Oh, maybe not. Ooh, maybe. Equal to the magnitude of A times RQ. This one's gonna be a little bit hard for me to visualize because A and C have this like offset. They don't start from the same point in this drawing. We do know the angle between them is beta because MN is parallel. So I think it might be helpful to redraw this picture to make A and C start from the same point. So I'm going to get rid of like half this drawing and worry about just A and C here. We know the angle between them is beta. And kind of hate that I would reuse R and Q in a different way than they're defined here, because A starts from P, but I want to say that A now starts from R if we shift it. I think we'll just do that. Hey, PMOH, can you just cut the norm of A in the equation? Since A dot C equals norm of A, norm of C. We're going to use that fact, certainly. So I won't say that you're being ignorant. It's like, that's actually going to be my next step here, figuring out what A dot C actually means. We're going to do some right triangle stuff to figure out what RQ is, but we're certainly going to need this fact that you said here. Now RQ is equal to, what's that, N? Or sorry, we're going to make the claim the magnitude of C is equal to Rn. Oh, I'm writing it wrong. Zach, thanks so much for the raid. Welcome in. Hope your stream was good. Did you finally get through that system? I hope so. You've been working on that problem for a while. We're now working on this proof involving dot products from Thunderfix in chat. We're nearly to the juicy part. Once we get through part 3, we'll be able to actually prove that the dot product is distributive. Hopefully, I haven't worked that part out in my head yet, but so for this part 3, I'm going to make the claim that the magnitude vector C is equal to Rn, the length of that segment. And I'm also using right triangles going to make the claim that Rn is equal to RQ cosine beta. And now I'm going to say that this magnitude of C is equal to Rn, which is equal to RQ cosine beta. Wait. Well, no, that's a weird way to show it. Let me say instead that why am I getting 2 cosine betas? Isn't that not right? I feel like, oh, I switched my RQ, my Rn. Because RQ is the adjacent. There we go. That's why adjacent over hypotenuse. So adjacent equals hypotenuse times cosine beta. There we go. I know trig, don't worry. Hey, Zach. Oh, sorry, I don't know if there's a computer lab playing or something, but I hope that you were able to get through that ODE problem. Okay, here's what we do. I don't know why this one is tripping me up in particular, but we're going to say that A dot C, I'm going to sub here that the magnitude of C is equal to Rn. I feel like I should make these proofs match in their form because they're so similar, maybe in all 3 of these, but I've known them I'm doing it 3 different ways each time. Okay, so I said the magnitude of C is equal to Rn, and then notice that Rn cosine beta is equal to Rq, and that's our proof. For part 3. Okay, that works. Hey, Kiz Says Boo, over on YouTube. How's it going? Okay. Now for part B. You did part B already? Oh, okay. I want to figure out what you're supposed to do. I still haven't figured that part out yet. But I won't go and like show on the board then if you already know it. So you can get, if you sub everything that we just found, you could say that A times, or could we somehow get that PQ is equal to PR plus RQ? PQ is equal to P. Oh, yes, we could do that. That's just the, okay. I see how part B works. You would say that A dot B plus C is equal to negative A times PQ. And then you notice that PQ is equal to PR plus RQ. And you could distribute to get A times PR plus A times RQ. And then notice, oh, that's A dot B plus A dot C. Okay. It's kind of nice. So there actually is a little like technical detail there, Thunder. I wouldn't divide everything through by A. That's a logical error. One last one. Well, like, it's not good form to work on both sides of the equations when you have a proof like that. You should start from one side and get to the other. So I assume what you did is you said that A dot B. This is what I've been told, that it's a logical error. I assume what you did here is you subbed everything and said that A times PQ equals A times PQ, or PR plus A times RQ. And then you divide everything through by A and found a true statement. But as soon as you work on both sides of the equation, you're assuming that this thing is actually true already. Like you've already assumed that the thing you're trying to prove is true. And that's why it's bad to do this. This is something that I would have done myself, so I don't have the best explanation for why, but it's not been corrected on many times where, yeah, that's what I would do instead, Thunder. I would start from, I mean, you can start from either side of the equation. I just start with this is equal to A dot, or A times PQ. And then say that PQ is equal to PR plus RQ. And then distribute, and these are all scalars, so we can distribute the scalar in. And then we use the subs that we proved in parts 2 and 3. And then going from this first part to the last part is your actual like proof. We've gotten to our goal. Yeah, it's the same idea as what you did. It's just the order with which you do things is important. You kind of cut to the chase prematurely by... I mean, there actually is a way to make that proof work. I just would not divide each side of the equation by A. Because that is implicitly saying that things are true. You could... if you don't do things on both sides of the equation, you could do that construction too. Or you could, instead of doing the exact thing that I did, you could factor the A out here and then say that PR plus RQ equals PQ. That's a valid way of proving this too. Let me actually show it. So I would not divide everything through by A. If you want to do this approach, I'd factor the A out here. PR plus RQ, and then know that PR plus RQ is PQ. And this, I would say, is a valid proof as well. Just do not work on both sides of the equations, just stick with one. Hey, Pro Young, can you do physics? Not really. I can't say I'm very good with physics at all, unfortunately. If it's something simple, then maybe, but I've forgotten a lot of physics. I have to do simultaneous equations when you're done, if that's okay. What type of simultaneous equations? Like, can you give me an example? I certainly can. And Ines, can you explain me arc length integral? Can you give me an example problem? Like, what kind of function you need to find the arc length of from what to what, ideally? I have a Discord where you can put screenshots as well, if that's easier. In the meantime, I'm going to look at what Thunder's other one is. So yeah, those are concepts that I can explain, but it's a lot easier if I see quadratic simultaneously. That's why I ask. Because that's very different from what I would have assumed. You find a question? Okay, thank you. So yeah, if you're doing quadratic simultaneous, you're going to need to do some kind of substitution or something. Oh, impulse. So yeah, if you want to pose a question, do it in the math discussion channel or the math homework help channel. And ideally put something in chat to let me know that you posted it. You're good, kids. Which one is it, Thunder? I guess I can look at the answer. And 15? Okay. Smooth velocity, it's a smooth ball. Okay. In the direction of the impulse received by the sphere. Okay. So, and I assume you're asking the impulse is that simple? Oh, I guess it's just vector subtraction. Wow, okay. So yeah, I assume you're more worried about part B though, right? So I was looking at part A just then. And that's, can you explain it generally? Okay, before I dive too much into the weeds of part B, let me quickly explain generally about arc length integrals to an S. I just have a hard time doing these kind of general explanations in S, so I'm going to link you to a resource you can go through for yourself more, but I'll kind of give a brief overview. So this is Paul's online notes. I love the site for everything calculus. It doesn't explain the actual theory of it very much, but if you just want to like get through your calculus class, it's the perfect site. So that's the link to it there. I'd recommend scrolling down and going through. They have the formulas here. They're given in kind of a weird way, but their examples are really well chosen and well explained. So, oh, PM, I think I saw you join the Discord, right? Do it in either math homework help, that channel, or math discussion, ideally. Oh, oh, okay. No worries, kids. And if you need to actually like at you in the channel or show you on my screen, I'm happy to do that too. So yeah, and as I'd say, if you're given your coordinates to find the arc length in terms of x, your integral will also be in terms of x here. So we're going to use this formula here and integrate it. So honestly, yeah, I recommend you just look through it for yourself, but the procedure is always the same with these. It's just, in this example here, they're saying y equals ln of secant of x between 0 is less than or equal to x is less than or equal to pi over 4. You would derive it to plug it in for dy by dx, and then just use the formula, and you get a normal integral after you've set it up. So since there's a few questions in the chat, I'm not going to say much more about it. If you have a quick question, I can definitely take a look at it. But it says Boo has y squared plus x squared equals 29, and x plus 7 equals y. Okay. Thunder, do you have a minute for me to do this system of equations? It shouldn't be that long of a problem. This one is it's gonna take me a little bit. Okay, thank you. And I see you, $10. I'm trying to think of the most obtuse way I can say to take the derivative, just to like mess with you, but I'm still trying to come up with like a really tedious way of saying it. Actually, are you okay with the phrase "take the derivative"? So I imagine that one's just as proper as differentiate. Just deriving it sounds cool though. Find the equation of the gradient, yeah. All right, so y squared plus x squared equals 29. And x plus 7 equals y. All right, so we have two equations, two unknowns. It should be possible to solve this. Now, these ones are a little bit trickier because we have y squared and x squared. So it got taught to me to solve these like as the first way. You do like, you multiply one of these equations through by a number and then you subtract the two equations. That doesn't really work here when things aren't linear. We have to do substitution as far as I know. And we're kind of given one of the substitutions for free. We know that y is equal to x plus 7. So let's just take this sub and bring it over here. So if we know that y is equal to x plus 7, then this y can become an x plus 7. Remember your parentheses for it squared. Plus x squared equals 29. And now we'll be able to solve for x just like a normal kind of quadratic problem here. So let's go through that. Not the same verb? Oh, okay. So if I multiply out x plus 7 squared, I get x squared plus 14x plus 49, then plus x squared is equal to 29. X squared and x squared combine to be 2x squared. 14x stays the same. And I'm going to subtract the 29 over to the left side. So 49 minus 29 is 20. Now we need to factor this. I'm going to divide each side through by 2 because we're allowed to do that. So we get x squared plus 7x plus 10 equals 0. This is a lot easier to factor. I'm going to name a number that multiplies to 10 and adds to 7. Sorry, two numbers that multiply to 10 and add to 7. Those numbers are 5 and 2. So this factors to x plus 5 times x plus 2 equals 0. Now we split it up into two equations. X plus 5 equals 0. And x plus 2 equals 0. On the left, we get x equals negative 5. On the right, we get x equals negative 2. So we get two different answers for x, and that's okay. We have to consider each of these individually and figure out what the y is that corresponds with them. And that just kind of happens when you have things that are squared, or like two lines can only ever intersect in one point, but two functions in general can intersect in many points. So it's okay that we get two things for x. So let's work on x equals -5 first and plug it into this equation up here. We could plug it into this equation, but it's a lot harder to work with. This one's a lot easier. So let's just use that. They both work though. -5 plus 7 equals y. -5 plus 7 is +2. So when x equals -5, y equals 2. So one of the points where they intersect is -5, 2. The other point where they intersect is going to be from x equals -2. -2 plus 7 is 5. So our second point is -2, 5. I'd say these two are both the answers here. And I see you saying, oh, okay, so it sounds like you understand what's happening. Okay, awesome. No worries. Those equations are kind of weird to solve, but they definitely do come up the farther you go in math, so it's good to know how to do them. Okay, so let's look at thunders. If you have more, I'm happy to work on them too. I'm just going to like switch off when there's multiple people asking questions, so. Small smooth sphere of mass m. It's a smooth wall. Some were given the initial and the result. Another one we weren't get. Yeah, it's this one down here, right? Yeah, I don't know. Anyway, that's not important. For part B, the coefficient of restitution between the sphere and the wall. In the direction of the impulse. Right, and only the direction perpendicular to the wall or in the direction of the impulse gets affected by the coefficient of restitution. Oh shoot, PMOH, I see you posted your problem too. I was originally in Portuguese, funny. Lord Kebab, thanks for the follow. All right, so PMOH, I do see your problem. I'll work on this right after I work on Thunders here, because I think I see a not bad explanation here. So we're learning currently in high school? Okay. Yeah, I'm pretty sure, I'm a little bit rusty on my probabilities, but I'm pretty sure that I can do that one. Let's, I want to figure out this dot product thing though. I think I figured out some kind of way to explain this. And actually doing that last one is kind of helping me work this through, I think. Okay, I hope I do this right. So the reason the dot product helps That's the wall. That's the first vector. That's the second vector. That's the impulse. I think we set up a right triangle here to try and explain this better. Two I plus 2j. So you understand nothing not unavailable? Oh, no worries, kebab. I've had to do problems that are like not this crazy with vectors and stuff too. And hey, Asit, let me know what you have to do with that problem. I have a couple people who've asked questions first, but it looks like something that I'd be able to do too. What am I trying? So I'm trying to figure out the proper way to phrase this, but what I want to do is draw the right triangle from here to here. And we're defining this impulse, we only care about direction, so we're gonna make it a unit vector of length 1. I'm just trying to debate how that helps us now though, or I think I'm drawing the right triangle wrong, which is an issue. Impulse equals change in momentum. Yeah, so I'm trying to. I don't remember if you were here for the discussion yesterday or not, but or not yesterday, but Saturday, I think. I'm trying to explain how what's happening with this line here, and what we're doing is getting the component of 5i minus 2j. Oh, no worries at all. So I was saying that because it was a whole discussion. That was a whole thing. And how does this dot product actually get us the component of the vector in the direction of the impulse? And I'm pretty sure it's because this impulse is just a unit vector, so it's length 1, which simplifies the formula for the dot product. So the entire dot product is to find the magnitude of the vector that's in the direction of the impulse, and then you multiply it with the actual direction of the impulse to make it a vector again. Why does the dot product give us the opposite? What do you mean the opposite? These cosines aren't supposed to get adjacent. Depends how you set up your right triangle. That's what I'm worrying about. It's if you're adjacent to the impulse, then you're doing exactly what you want. The right triangle that I drew doesn't feel quite right though. You may have cooked something. Oh, please let me know. Okay. Maybe a general version of this is better. Okay. It is the same thing as a projection, but I don't think Thunder is done projections, which is why I'm trying to avoid using that. I think we can say basically a projection though. If I just generally have two vectors, let's call it vector A and vector B. I'm going to say the magnitude vector B is a unit vector, or so it's length 1, and that's going to be like our impulse vector. So if we do A, oh my gosh. So if we do A dot B, that's equal to the magnitude of A times the magnitude of B times cosine of the angle between them, theta. But we know the magnitude of B is 1, so we can also write it's the magnitude of A times cosine theta. And if you notice, if we draw this right triangle, adjacent over hypotenuse. Why isn't A the hypotenuse? This still isn't working. Dang it! What's up? Oh, you sent it, Thunder? Yes, Dookie, it's basically what we were doing on Saturday, too. I mean, that language YouTube isn't a fan of, and I'd rather not have it around, but I appreciate the kind words. Yeah, I just realized that my right triangle thing doesn't work the way that I hoped it would. Thank you, man. All right. Well, what did you cook here? This is alpha. This is 90 plus alpha. Oh, sure, because this angle here is equal to this angle there. And then we're saying that's, yeah, that's a right angle. Okay. Hey, Star, I'm doing good. How about you? I'm not sure how this helps us. That's good to hear. Okay, let me... I don't think you've learned this, Thunder, but I need to see how this works. It's basically vector per projection. Oh, you also DM'd some text. Cosine 90 plus alpha is the same as sine alpha. Yeah, 90 plus alpha might be negative sine. I think it's negative sine. Or is it? Dude, I'm so bad with those trig formulas. That's making cosine to the left by pi over 2. Which I think is negative sine if I'm visualizing it right. Five I minus 2j dot impulse. So why is this sine alpha thing helpful? I mean, we're just talking about magnitudes here, so we could just make it positive. Why do you prefer this being in sine alpha? It might be helpful. I was trying to figure out why. Oh, that's what you're saying. Yeah, so I was getting tripped up on this vector is pointing into the end of that vector. Uh, that's why that's why I was getting so confused on how this dot product thing actually works. Um, I think Zach actually said that the last time that dot product with an obtuse angle, like we would have here, like this angle right here is obtuse, would get you a negative number. But yeah, you could just make it positive. I don't get what you're trying to pull. Still. I agree with that. If you get minus sign alpha, you get the opposite. Yeah, that would be the direction that we do want. I don't know if it works. I don't know why it works. I can't. I don't know. It feels intuitively like it should work. I'm just having trouble actually explaining why. Like I don't know if I think what you said so far is true. I don't understand where you're going with it still. A dot B is negative. True. So that's why in the other problem we had to stick another negative sign in front. They probably did the same thing here. Yeah. It's like you're allowed to do that substitution. It doesn't like fix the fundamental issue though. Like I still don't the right triangle is not working out in my head, and I feel like if I could just make it work. Oh, and then you're saying that we do want the opposite. Because with sine. How does having the opposite help us? Opposite is the perpendicular. I'm trying to figure out perpendicular to what is the issue. Oh, perpendicular to here. if that is alpha. I guess I have a hard time saying that this construction is definitely right with. I think it's right. I just. What I'm trying to figure out is the vector is still pointing into one end of the other. I wanted to make it work so that they both start from the same point, but this impulse vector is still pointing in to the start of the other. Okay. And I feel like I'm keeping a couple people waiting now, so I'm trying to figure out. I'm just have to bring up PMOH's problem too, but like so let me try and figure out in the meantime while you work on that, because the probability of B complement. We need the formula for conditional probability here. P of B given a Sentinel diagram? Okay, let me look at that. Well, over here they start from the same point, but the alpha is over here. And so if we take sign of that alpha, that's where I was getting confused. I think it's okay because we're sticking the negative sign in front of one of these vectors, so we're reversing its direction. So for the same reason you said, like, we're going to get a negative answer here, and that we don't want that. We have to make it positive. I think since we're expecting that negative result for the dot product, so we're going to add another negative sign in front just to compensate. I have too many tabs open. Okay, you know what? Who even cares? I think we're actually like, if I redraw it, we're actually reversing like this vector here, for instance. We could reverse either. But I just took that vector as the one that we're reversing. And then if we dot these, cosine theta equals adjacent 1 over hypotenuse magnitude of minus 5i plus 2j. Is that what we want? No, that's not even the magnitude though. That's where I'm getting tripped up. It's not. That isn't true what I just said. I'm sorry, Thunder, I just don't know. I can't make this work in my head. And there's like two other problems that are waiting too. I'm not sure. Yeah, I am sorry. I just can't figure out this. It is just a vector projection, but I can't figure it out in this case. PMOH, if you are still here, I'm sorry about the wait, but let me work on your problem. I'll type in chat too in case you maybe have the stream on mute. So yeah, if we're given these facts, how can we figure out? Yeah, Fenvox, I just can't. I know that having the unit vector there is going to make it simpler, but I still can't figure it out, and it's causing me anxiety when I can't answer someone's question, and then I have other questions that are also waiting. Like, do I move on or do I keep working on that question? So I still don't know what to do, but for now I'm just going to try and get other people's questions answered. We want probability to be complement. Hey, SPQ. So we can figure out the probability of A intersect B and A complement union B. That seems like it would be helpful. I think I need a Venn diagram to figure out how to actually combine these. Make sense to your head? You know, that's the most important part. It doesn't make sense in my head, but it makes sense in your head. That's more important. Let me type to PM in Discord as well. Okay. .75, I'll write it with a comma. P of A complement union B equals 0.10. P of A intersect B over P of A equals 0.6. Hey, Zamilo? E to the pi I equals -1? Those numbers don't make sense. Fembox, I didn't even like actually think about them. What's wrong with them? B complement. So we figure out what P of A intersect B is if we substitute that equals 0.6, which means P of A intersect B 0.45. If you use De Morgan's on the second one, you get P of A and not B equals 0.9. P of A and not B. Do use De Morgan's on the second one. Hey, Milk. Oh, if it does, I don't see where, so that I might need that. I was gonna do it like a Venn diagram way. Why would P of A and not B being 0.9 not work? I don't see why that... Oh, A and not B. Okay. I was thinking of or. Wouldn't it be or not B though? I know, I assume we can still just get a number even if these don't make sense. Like it might be randomly generated numbers. But if you De Morgan's that, wouldn't this turn into an or? And in that case, we might be okay. Okay, so PMOH, all I've done so far is I plugged in the P of A that we're given there, down there, to figure out what P of A intersect B is. I don't know if that's going to be helpful yet. But my thought is that a Venn diagram is going to come in handy here. Can say this is A, this is B. We know the intersection. That looks weird, right? I shouldn't draw it like that. We know that their intersection, from what I just said, is 0.45. We'll shade it. Oh, it is or, you're right. I can't read. You're right, it would turn into and. So there's something weird with the numbers that were given in the problem then. But I think you can still go through the motions that they want you to do and get a number. But the problem doesn't seem consistent with itself. Let's just at least pretend like the numbers do make sense and get an answer though. So the intersection is 0.45. Probability of all of A, or probability of just A is 0.75 minus 0.45, which is 0.35. Oh, you made a mistake in the problem? Oh, okay, please let me know. P of complement A and B. Oh, okay. And in that case, we're okay. Because then it turns into or. No, you're completely fine. That stuff happens. Okay. So we're on the probability of not B. So B is that circle there. We know what probability of just, or we know the probability of A minus A intersection is, that part in red, 0.35. So we need to figure out kind of everything that's in the universe outside of here. Actually, I guess, or we can figure out what's in just B, I guess. We can figure out what's not in B. The probability of not A intersect B, isn't it the same as probability of just B minus the intersection? Because not A is everything around here, but and not the, it's not the middle part and it's not the just A part, but it's everything else. And if you intersect it with all of B, you get just this part inside here. So I think we can make the claim that P of A complement intersect B is equal to P of B minus P of A intersect B, right? And we're done. Yeah, okay. So we know what their intersection is. And wait, are we done? Why am I getting stupid? We know the intersection is. We don't know what probability of B in general is. Wait, where was I going with this? Oh yeah, because we know what, okay, yeah, this is 0.1. That's where, okay. I forgot that we knew what that number was right there. Minus 0.45. So we add that over. 5 is equal to probability of B. And so if we want the probability of B complement, we do 1 minus that, which is 4/5. Okay. Point 0.3 in the red part though, not 0.35. Oops. It is? How do I get 0.35? Their intersection is 0.45. Oh, you're right. $10. Just 0.3 there. I guess we didn't need that though, right? It's good to be more accurate. I don't think we ended up using that though anyway. Okay, so did that make sense, HemoH? I didn't do the best job of explaining because I got confused myself there. Yep, okay. Thanks for asking the question. See, you were talking to the other person who posted the problem. Let me take a look at it for myself, though. So this one from Robabs. 5 unaligned points, 3 to 3. I'll copy paste into the Twitch chat, too. I mean, I can show it on the Discord, I guess. So we can follow along with the conversation that's happened. So the original post is, consider in a plane 5 unaligned points, 3 to 3. How many can we form pentagons with 5 points? Or I guess how many pentagons can we form with those 5 points? See, I don't know what 3 to 3 bit means either. Take 3 points randomly, they're not aligned. Okay, so none of the 3 points are collinear. That makes sense then. You can make 12 pentagons. Oh, is it really? Of naming the vertices thing? How'd you get 12? It's not 5 factorial, it's not 4 factorial, it's not 3 factorial. So PMOH, I think I agree with what you're saying that geometrically it's the same exact pentagon. I think the question is really how many unique orders of the vertices are there? Not rotations, but permutations, I guess. They said the word combinatorial geometry, so I don't think the geometry part is really that important, but they said the answer is 12. I don't think it's as simple as 5 factorial. If you hold A fixed, well, I guess is that a good idea? Yeah, because rotations are... It feels like one of those where you hold like one of the points fixed or something. Maybe not. Or, I mean, maybe it's... How do you get 12 though? Because 5 factorial is 5 times 4 is 20. Times 6 is 120, so it's definitely not as simple as 5 factorial. I could see it being 5 factorial divided, or like 5 factorial divided by 5, choose 5 to get rid of rotations. But then 5 chooses 5. Oh, that's 1, isn't it? I was getting it mixed up. Never mind. How do you get rid of these rotations? Because if we do say, if we do start with 5 factorial, we need to, that comes out to be 120. If the answer is 12, we have to divide by 5 and divide by 2. If we're saying that rotations are fundamentally the same thing, I guess... Well, isn't the permutation still capturing those rotations? What if you do 5 factorial? So we need to get rid of them. I don't know why... I mean, I guess I know why. I feel like we could even forget about the whole pentagon thing here. And maybe think about it a different way. Like, we could just take it as 1, 2, 3, 4, 5. Our options are A, B, C, D, E. And so normally that would be 5 factorial. But we would consider, I guess, like shifts to be the same thing. So if we shifted this to the left one, E would come out front. So how can we, like, that's how I'm thinking of the problem now. I don't know if that's more helpful in trying to figure out what we actually want to divide by, though. I guess you could say that each one of these has, you can shift it once, twice, 3 times, 4 times, and the 5th time you're back to the original. So each one has 4 shifts, but we want to... combinatorics is not my strong suit. Yeah, I'll be divided by 4, and that doesn't seem right. Unenthusiastic. You get the first vertex for free, call it A. There are 2 ways to put B down, either adjacent to A or not. Then CDE gives you 3 times... Oh god. See, I don't understand that, so to me it feels reverse engineered right now. So I don't understand... I think you get the first vertex for free, call it A. I guess I'm on board with that. Then there are 2 ways to put B down, either adjacent to A or not. Well then either C is adjacent to B or not. Yeah. Which is fair, that's what I'm trying to do too. Just like either putting adjacent to B or not is where I'm getting tripped up. Like, why can't you say that about everything? Once A and B are chosen, we've lost our degrees of freedom. Really? Let's try one. So we just take A for free as the first one. Let's start with, I guess, adjacent. Then C, D, and E, we're making the claim that that becomes a normal 3 times 2 times 1 thing. And if we say 2, 3, 4, 5, we're taking B not adjacent. I know, I don't understand it. Like, but again, my issue with combinatorics is that I never know why something is wrong. So I have a hard time saying why it would be wrong. I just... You make any pentagon you like and hand it to you. I'll rotate it so that A is at the bottom. Then look at where B is. It's one of 2 types of pentagon. Oh. I mean, I don't like calling people out to like, hey, solve a problem for me unless I really need to, but I definitely wouldn't mind being saved on this one. That's a neat train of thought. Does that mean we divide by 2? Wait, actually, what is this actually justifying? We have... You're saying we're doing 2. Never mind. I was still stuck on 5 factorial divided by 5 times 2. But you're actually like, rather than eliminating, you're like constructing. So you're doing 2 times 3 times 2. I don't think these are the right terms. That's just how I'm phrasing it in my head, though. Like constructing and not. Google, save me. Oh, okay. It's desperate times, which means we're looking at Quora. Are reflections considered distinct? Maybe? Okay. Quora, you failed me. Number of cyclic permutations is n minus 1 factorial divided by 2? Because there's just a formula for this? So, in Finbox, this is the idea that you're saying, I think. Dividing it by 2 to consider reflections distinct. Or, sorry, not distinct. Polygon cyclic permutations. Oh. No, don't use pi as something that isn't 3.141592. Okay, I mean, it's just a cyclic. I just had it there. On this one? Or you mean on the Quora? Or sorry, it's sec or I don't know what I was looking at. I mean, this is a different kind of pentagon. I think this is ultimately the same thing. I think this comes out to be the same thing as the different permutations of the vertices, because you can still draw a normal pentagon around these. N factorial over 2n, which is the same formula. It is the same thing, I guess. Okay. So I think we can maybe... I don't know if we want to show that page necessarily, but... Actually, Robot, if you are here in chat, I don't know if you've been following the conversation, but I'll get back to you in Discord too, just in case, unless I see you speak up somewhere. Okay, yeah. So the difference is we've been translating A, B, C, D, and E, but I guess they draw it without changing their positions. Okay, that's fair. Permutations. And there's a simple formula. N factorial over 2n, or equivalently, n minus 1 factorial over 2. Would get us the answer of 12. The idea is you take a as fixed, so there are n minus 1 permutations of the remaining vertices, but you divide by 2 to compensate for the justification was clockwise versus counterclockwise. Is that a nice way of saying it? Polygons intersect themselves. I don't know if there is a type of shape where you're allowed to intersect, where that is allowed to intersect itself. I don't know if they're considered polygons or not, but I do know that self-intersecting shapes are a thing. I know nothing about how they actually work, though. Being the same. What's up? Counting clockwise, counterclockwise should be equal. This site explains it a little more, although they show the geometry a little different. Okay. Okay, they said thanks. Oh, you know, Protocol hasn't shown up to the stream, and I realized they posted some questions yesterday. I'm just because it seems like if Protocol doesn't show up by the time I end stream, I guess I'll get back to them in Discord. Sounds good, PMH. Thanks so much for hanging out and for helping out with that question too. If you or anyone else who's new around here or interested in more math streams, here's a whole list of streamers that people all do math help that I can recommend highly. Of course, no pressure to do anything at all, but if I'm ever not on, you need some help, they're around too. I should give out saves because PMOH helped out with that problem and Fenbox helped out with that problem, right? Oh, and SPQ is helping out with the probability one. Okay. Okay. I don't think there's any other questions from chat, but if I'm wrong, please correct me. which means we might go back to doing algebra. I could go back to trying to figure out Thunder's thing. I think I figured out why Thunder's thing actually works. Wait. Why sine of alpha is a good thing? Because the hypotenuse is 1. No, I lost it. The magnitude of A is still weird. You know, okay, vector projection. I'm sure that Thunder's gone by now, but I want to look one more time at vector projection. What's the formula of that again? Because I was looking at this formula, but I couldn't really figure it out. Projection. The question we want to answer is which vector we're projecting onto what? We're projecting, we want the component of this that is in line with the impulse. So our velocity is this vector up here, and we want the component that's in line with the impulse. So it's the projection, how do you say it, of V onto U. Okay. Which is V dot U over the magnitude of U squared, which is 1 times U. So this is literally just the formula for projection. And oh, you know what my issue was? I was discounting this part of the formula here. I thought that was a separate thing, but no, that's actually included. Okay. So if U is a unit vector here, you really just get the magnitude of V times cosine of the angle between them. Okay, I think I get it now. Because we're only, for the sake of this part here, it's like we're only considering the unit vector version. Well, is it? Not necessarily the unit vector, just whatever gets us that perfect right triangle. Like, it doesn't matter if U goes longer, is what I was getting stuck on. Okay, I'm gonna send this link to Thunder in case it helps, but I think Thunder basically figured this out the hard way. So I'm just writing quick DM to Thunder here. Okay. Okay. I'm probably not gonna stream for a ton longer because my voice still isn't fully back, but I can go for a bit longer. I think I want to do a little more abstract algebra reading. And then if nothing comes up, we'll wrap things up. I do need to take a bathroom break though, so I'm gonna be right back in like 2 minutes. Okay. So yeah, like I said, we'll just a little bit of abstract algebra reading, then probably wrap things up. So talking about cyclic groups. Oh, good. I've read all of half a page so far. Huge progress. Give me some examples of cyclic groups, and we're on this not example. U of A is not a cyclic group because none of these generate the group. Another way of saying that, I guess none of these elements have order 4. Like, you need an element with equal order to order the entire group. A GB group, let A belong G. If A is infinite order, then A to the I equals A to the J if and only if I equals J. Hey, Brian. How's it going? So this has nothing to do with cyclic groups so far. I was getting a little weirded out by that. You were there? What's there? Or there for what, I guess. Oh, really? I mean, you don't say if you don't want, but like, what were you doing? If and only if n divides I minus j. Visiting Apple HQ. Oh, cool. Were they having an event, or were you interviewing, or? Either way, that sounds awesome. Yeah, I don't think that's far from me. I can't remember exactly where they are, but I'm sure they're somewhere not far. But a very expensive t-shirt. That sounds like Apple. Well, awesome. Yeah, I imagine they have imagine it like an Apple store where it's very like almost like sterile, like very clean. Dude, Apple stores are kind of a trip in general, but by the way, I hope your visit was good. What is this n divides I minus j thing? Uh, Anya Key, Anya K, Anya. Thanks for the follow. Your mugshot in front of an Apple visitor sign. Okay, nice. I mean, it's a nice place to take a mugshot. So if I minus j is less than n, then yeah, okay, these are certainly distinct elements. If you have anything about it in terms like if you have a group of order 6, then I guess I can see how a squared equals a to the 8th. Okay. I guess I'm on board with that. If A has infinite order, there is no non-zero n such that A to the n is the identity. Really? Talking about studying like the abstract algebra stuff? Sure, I guess. Like, what do you have in mind? I could generally, if you want, like, put stuff in chat. Like, you can always feel free to like do that. What I've just been doing is going through chapter 4 of this book for Penn Center's reading group. I meant to do it off stream, to be honest, but I have a little bit of time that I want to fill before ending stream, so ton of problems from this chapter over the last few days. Got stuck on a few. Yeah, I'm. I was working a little bit on Penn Center's abstract algebra stream, or the Penn Center stream on Sunday. I think I got as far as problem 15. Oh my god. That one might not. Ooh, I don't know. This one, it looks complicated. It might not be that bad though, to be honest. I imagine there's gonna be some crazier ones towards the end. Usually the first few are pretty like computational. Hey, Gold. Abelian, my dear friend. Yeah, I, I don't want to talk to any group that's non-abelian. Abelian groups are much nicer. This elements of order 8, is that 8 million? It is. Hopefully we get some kind of tool to actually do that with. 86, yeah. You know your list is complete. The order of A is 8 million. Isn't that just gonna, well, no. I guess that's the same thing asking what the generator of the group is. I don't know. I don't know why I'm skipping ahead to look at these, but of order 8 would be 1e8? I have no clue. Oh wait, order 8. The order is, so this is integers mod 8 million, or integer addition mod 8 million. And order 8 is how many times you would add it with itself to get back to the identity, which is 0. So I think your example of 1e8 would work, because you add it to itself 8 times, and when you do 8 million mod 8 million, you get 0. So yeah, that's definitely one of them. Could there be another one? I guess not, because we're talking about addition. And then I guess this one would actually just be 1. You feel smart today? Yeah. I can't imagine there'd be others. Yeah, Gold, I need anything like you have with the what's his name? Walk doing the well done. Well done. There's at least 2? Of order 8. I feel like this is really just asking 8 million divided by 8 is what number, and there's only one, which is a million. I can't figure out what another one would be. Oh, wait. No. Never mind. I was wondering if there'd be like a whole range of numbers, like 1,000,000 to 1,900,999, but no. It's always something or zero. I think zero, the order of the identity is always one, I think. It could be, or there might be like 3 million or something. Oh yeah, because maybe something times 8 is 0 mod 8. Or, oh, shoot, what would it be? It's like if you, like 2 million is order 4, but 3 million, which does not go into 8, what's the order of 3 million? 3 million is 6 million. Plus another 3 million is 9 million, which becomes 1 million. Plus 3 million again is 4 million. Plus 3 million again is 7 million. Plus 3 million again is 2 million. And then 2 more 3 millions gets you order 8. Ah, that's why. I assume it's going to be the relatively prime millions. Or, like relatively prime, like it's going to be 1, 3, 5, and 7. Because 5 and 5 million is 10 million. Which becomes 2, which becomes 7 million. And then 12 million becomes 3 million. No? 4 million. 5 million becomes, or 9 million becomes 1 million. 6 million. 11 million becomes 3 million. Yeah, okay. So 135, and I'm just going to say that 7 million also is. I don't want to do that math. See, who even needs to read the actual chapter? We're already solving these. I'm going to say that for this part of the question, actually, I don't know how I know it's complete. Like, I don't know what's... Everything else is going to have too weird of an offset, I guess. It's going to be some huge order. That's not an actual proof, though. Or it'd be a smaller order if it goes into 8 million. If it's like 2 million or 4 million. What about 6? 6 million is going to be order 3, right? Yeah. No? Order 4. It can be order 3. 3 doesn't go into 8 million. I'm going to say that this one, though, A equals 1. All elements of order 8 in the group generated by A. Well, A generates the group. So it's going to be the same thing? I don't know. Anyway, we should probably get back to the actual reading, but... Hey, Anders. I just realized that I worked ahead of Penn Center again. I guess I'm being too strict about it anyway, but... Oh, well, okay, let's back to the actual... the reading. So I was just making sense of this part of the definition. I think I'm on board with it. Let's see what the proof is like. If A has infinite order... Oh, wait, this part was super weird to me because... Shouldn't there always be a non-zero n? Such that A to the n is the identity? If you have integer addition and you take, even 4, wouldn't you do 4 minus 4 is 0? So or it's always like the inverse. I don't remember. It's been defined the opposite group. We don't, I didn't know the term opposite group even existed. That has not been defined as far as I know. I'm just starting the reading for chapter 4 for what it's worth. Oh, duh. I see why this... Okay. It's not just the inverse. It would be a to the n times a to the negative n is equal to a to the 0, which is not non-zero. Okay. For the infinite order part. Oh. Yeah, I have no clue. Yeah, except for k equals 0. So I guess that's fair. Since a to the I equals a to the j, implies a to the I minus j. Oh, sure, if you write and multiply a to the negative j, it said that I minus j equals 0. And the first statement of the theorem is proved. Oh, okay, fair enough. Assume that the order of A is n. I assume for the finite part. I thought this was a definition. The subgroup generated by A is just this, isn't it? Two different groups with elements of no order. I think every element always has an order. It might be infinite order. Oh, is no order another way of saying that? Or like, a convention that's also used? Well, integer addition in integers without 0 multiplication. No finite order. Oh, okay. I think just about any group with an infinite set would probably do it. If it's finite, the order of each element must be finite. Suppose that A to the K is an arbitrary member of the subgroup generated by A. By division algorithm, there exist integers Q and R. Sure. Integers without 0. And then I think it's all good. Or hell, you could do like general linear group with like matrices too, I guess. It still might not. Oh, dang it. Okay, rational number multiplication without 0. You're right. Yeah, I guess integer multiplication is never a group unless you have mod. You know, I feel like Zone Ranger showed this exact type of proof for a problem from chapter 3. I forget what it was though. You must keep the integers in check, yeah. Those integers are wily. Without C or Z or Q or R. I mean, unless you want to get into matrices, I don't think so. But matrices are still C, Z, Q, or R. There might be some kind of thing with like functions. We don't have very many examples of group. I mean, I feel like the book so far hasn't introduced us to that many different types of groups. Functions is what you're thinking? Okay. Yeah, the book's only barely talked about like functions. So I'm not that confident with like what exactly, like would you take the set of all functions with composition or something? Linear functions f of x equals 0 and addition. Really? Huh. Isn't f of x equals 0 just a single function though? Linear functions with f of x equals 0. That, I mean that, oh, that like pass through the origin? Okay, okay. That would be a group, I guess. Yeah, okay. Like, we were saying like there exists an x such that f of x equals 0. Okay, I'm curious. I remember what problem that we were looking at with Zone Ranger. I think it was later on here. Oh, yeah. It was 77, I think. This book does do a nice job of hinting at what you're going to next with these problems. I do kind of like that. Or like guiding you to some kind of realization. So I think this proof is that like these elements are clearly in the subgroup generated by A by definition, but there aren't any other elements also in there, is what they're saying. With y equals 0. Really? But it's all equal to 0. If it's y equals 0, though, isn't it just a horizontal line? Like, what is all that stuff then? Like, how is this a two-variable function if y is always 0? I guess functions in general have the same issue as I said with like matrices, where like I guess that they're a little more abstracted, but it's still a function of real numbers, rationals, or complex or whatever. Y equals 0 is the identity. Oh, for addition. Oh, I get it. Okay, okay. Y isn't always 0, but that's the identity. Okay, that makes sense. And you can always find an inverse function, or the inverse of a line, even if your y-intercept is 0. Okay, yeah. Something like, oh, or like it's, like that'd be like a special case where like it'd be a polynomial of infinite degrees, some might say, and then y equals any non-zero number is degree 1 or something like that. I don't remember the justification for y. I think because, yeah, you could say 0x plus 0 or 0x squared. Yeah, okay. Yeah, it's ambiguous where that 0 comes from. Okay. All right, so they've proven this. We assume that a equals a to the j. That's why we assume this and prove that. I was like, you can't just assume like this part also, right? But no, they're trying to prove that. Okay. Hmm. Okay. Your polynomials book defines the degree of the zero polynomial as a negative infinity. Why negative infinity? Oh. Oh, okay. It's one of the classic mathematicians things that this makes no sense, but it's convenient for other things, so we'll say it's true. Subtract two monopolynomials of the same degree. Supposed to get an answer of lower degree. Oh. Or I guess lower or equal to, I would think. I mean, if it's or equal to, I don't know. But what is negative infinity minus negative infinity? I'm sure there's a good reason why, but when I say that, I kind of like wonder why you can't make that same statement, just make it apply to degree greater than or equal to 0. I feel now negative exponents, I feel like those wouldn't be considered polynomials. It's because they'd be discontinuous, right? If nothing else. Or they have a discontinuity is a better way of saying that. I think that'll break too many things for a lot of people doing math. Oh, in the series sense? I guess so. Yeah, I mean, I guess you could make a Taylor series. Hardlocked. The end. Thanks so much for the 9 months, Hardlocked. I feel like only certain alerts are playing. I need to look into why Stream Elements is doing what it's doing, but either way, I appreciate you, Hardlocked. Thank you very much. Some polynomial series that have negative exponents. Really? Would I have seen them? Or are they like exotic? Like, would I find one in this list? If the list actually comes up. Come on. Come on. You can do it. Any day now. Laurent series? Okay. Dude. Okay, fine. I don't get to know common series. Are Laurent series a polynomial? I mean, if it's a series, I guess. Oh, this one is only negative exponents. I'd assume a series isn't necessarily a polynomial, I guess, though. Wouldn't that be the distinction? It's called, this is the analytic part. This is the singular or principal part. I don't know. Well, a series, it's just a summation, though. If we're playing fast and loose with series versus polynomial. But I'm probably the last person to ask about that anyway. If to the k equals e, then n divides k. Yeah. If A and B belong to a finite group and those two elements commute, not necessarily it's a abelian group, then AB divides magnitude of A times magnitude of B, or order, I should say. I'm stuck on vectors. If you keep integrating, you get negative exponents. Oh, I don't know. Oh, that one. I think someone said an answer somewhere. I think maybe someone posted in the Discord later. I don't remember. I don't know. Maybe someone put it in chat. Oh yeah, but like relating it to a polynomial is still like kind of crazy to me that that has any relationship with a polynomial of degree 7. You love abelian group theory? Oh, nice. I know basically nothing about it, but so far I'm still not very enthusiastic about algebra. I just think it's good to actually know. How much more reading is there to do in this? I know I've only barely gotten far, so I shouldn't be complaining. No, we haven't gotten into I don't know if it's still called our Cartesian product and when you're talking about groups, but like whatever that is for groups, we haven't gotten there yet. I think in like 2 more chapters we'll get into isomorphisms, which I think is where that maybe comes up. I don't actually know though. Sherlock, thanks for the follow. Yeah, I know in general that R cross R is every possible pair of elements with R and R, so it's basically like an XY coordinate. You can imagine Z cross Z, yeah. Hey, Sherlock. Did I get enough sleep? I like to think so. Chapter 8 is direct products. Oh, okay. Yeah, just integer coordinates. So because these 2 elements commute, we can make the claim that this equals that. And AB, the order of AB divides that. Okay, yeah. Theorem 4.1. Okay, yeah. Yeah, so the integers mod 2 cross with integers mod 2. Okay, fair enough, yeah. Almost like it's a cyclic group. Actually, well, that's not necessarily a cyclic group, is it? It might not have a generator still. I guess not, yeah, okay. Never mind. It's in a circle though, which makes you want to call it a cycle, but I guess that you could do that with like U8 or whatever example they said that isn't cyclic. A is a generator? I guess they're just talking about whatever subgroup is generated by A. And that subgroup is always cyclic because it's literally just every power of A. Okay. So it is cyclic. Just not of the entire group, just of the subgroup. I lost where I was. There we go. Whoa, that's some crazy autocorrect that happens there. That happened there. Your professor studied Z2 cross Z2 cross Z2 or times the direct product. I don't know. Every element except 0 has order 2. Huh. For if you do addition like 0, 1 plus 1, 1, I assume you do it like the x with the x and the y with the y, for lack of a better term. It's probably not good to call them by coordinates like that, but if I do that, you would get 0 plus 1 is 1, 1 plus 1 is 0, and then... Wait, no, that's not what it means, Seb. That, I'm doing the order wrong. Whatever you do, if you add it to itself, you get back to 0, 0. Okay. Yeah, okay, and that's like the general way to like add those. But I just realized I thought that would lead me to the order, but of course it wouldn't. You'd have to do 0, 1 plus 0, 1 is 0, 0. 1, 1 plus 1, 1 is 0, 0. I guess it makes sense. Well, I mean, I guess even by elimination, only the identity can have order 1. The identity is unique. And then everything else has to have order 2 because there's no other things that divide 2, right? Lagrange's theorem or whatever. We haven't actually gotten to Lagrange's, but we've talked about it so much that I think that's what it says. Oh shoot, I've streamed for a little longer than I intended to. I don't want to push it because my voice is still pretty sketchy. I might want to wrap things up here. I'm going to try to read through chapter 4 if I can off stream, because I feel like it's better to do the reading off stream than do problems on stream if I can help it. Also, I need to fill in some more time on Thursday, but hopefully I will have read it by then. Should you technically study rings like that? Oh, okay. I imagine it applies similarly though. We have options for who to raid. Actually, let me cut off the YouTube stream here. If you're on YouTube, I appreciate you. I'll be back on YouTube on Thursday. That's the day.